We're going to be working on simplifying radicals. Also, you will see imaginary numbers and complex numbers in our lecture today. Now, we know that square root of 4 is 2, and square root of 9 is 3, square root of 100 is 10, and square root of 1 is 1. Now, all these examples are perfect square because we can have an integer or a whole number if we simplify the following numbers using a square root. However, sometimes it's not always the case, like for number 7, number 8, and number 9. Sometimes, even if it's not a perfect square, we can still simplify the radical, and that's what we're going to be doing today because we will need this in our lesson on imaginary numbers. So how do we simplify radicals? So square root of 12, we know that there's no same numbers that when you multiply by itself will be equal to 12. But we know that we can factor out 12 and find a factor that has a perfect square, and that's what we're going to do. So 12, it has several factors. We can use 4 and 3, we can use 6 and 2, or we can use 12 and 1. But I chose 4 and 3 because that's the first factor that I thought of. So I have 4 and 3. So this is my first factor. I know 3 is already a prime number, so I'm not going to be able to factor this out anymore, but 4 can still be factored out. And 4 is equal to 2 and 2, or the factors of 4 is simply 2 and 2 because 2 times 2 is 4. Now we know that 2 is already prime, so we're going to stop our factor tree method from when we get a prime number. So since we have 3 roots or 3 endpoints, we have a pair of 2 right here, and whenever you have a pair in a factor tree, you can place it or write it out outside the radical. And if you have a single number without any pair, it stays inside the radical. So 3 will stay inside. So we know that square root of 12 is simply equal to 2 square root of 3. So this is its simplest form. Now for number 8, we have square root of 50. And we know that square root of 50 has a factor of 25 and 2. So 25 and 2 can still be factored out because 25 can still be factored out into 5 and 5. So now we have 2, 5, and 5 as our roots. We call it roots because it's in our endpoints. So we have a pair of 5, 1, 2. So if we have a pair, it can go outside the radical. So this pair of 5 will be outside. And since 2 is single and it doesn't have any partner, it will stay inside the radical. So pairs can go outside the radical, and the single numbers will stay inside. Like this one, we only have 2 as a single number, so 2 will stay inside. Now for the last example, we have 32. Now the factor of 32 is 8 and 4, and we can take several factors for 8 and 4. So 8 will be factored out into 4 and 2, and 4 can still be factored out into 2 and 2. However, we know that 4 can still be factored out, and we have 2 and 2 on this side of our factor tree. Now, the roots that we have 1, 2, 3, 4, 5. We have 5 roots. And in those 5 roots, we have 2 pairs. So we have a pair of 2. So let's write it out here. So this is my first pair of 2. And we have another pair of 2 right here. And let's put it right here. So since there are 2 pairs of 2, we can multiply them together. Therefore, the 2 pairs is combined as 4. So 2 times 2 is 4. So this 4 right here will stay outside the radical. How about the other 2 right here? So this 2 doesn't have a partner. So since it doesn't have a partner, it will stay inside the radical. So therefore, square root of 32 is simply 4 square root of 2. So that's how we simplify radical. Now we know from our previous lesson that square root of negative 3 is undefined. So every time you solve for x in a quadratic equation and you end up with a negative or a square root of a negative number, we automatically write undefined. But this time, we're not going to write undefined anymore. We are introducing the imaginary number I. So if we have square root of negative 3, we know it's undefined. And if we solve for x for number 2, we'll end up with plus or minus square root of negative 2, and it will still be undefined. But now we know that square root of negative 1, or any number that is negative inside the square root, can be replaced by I, which is your imaginary number. So now, instead of writing undefined, we are replacing the negative number by I. So making sure that that negative number is inside the square root. So for example, for number 1, square root of negative 3 is no longer undefined. Square root of negative 3 is I square root of 3. Now, notice that I'm always writing out my I outside the radical. The reason why I don't usually write my I right after the radical is because sometimes people mistake it as square root of 3i. And square root of 3i is not the same as I squared of 3. So to avoid this error, write all your i's outside the radical whenever you're working with a radical and a number that cannot be simplified. So for number 2, I have square root of negative 2. I'm writing it as I square root of 2. But for number 3, since 81 is a perfect square, and I know that square root of 81 is 9, instead of writing I 9, I can write this as 9i because this is in standard form. So that's how I usually write my imaginary numbers for radical form and for an integer form or a whole number. So for number 4, I have square root of negative 8, and 8 is not a perfect square, but we know we can factor it out into 4 times 2, and 4 is a square root of 2. So using the factor tree, square root of negative 8 is simply 2i squared of 2. So this is how we use the imaginary number. So it's no longer undefined, now it's the imaginary number I. Now, how are we going to solve quadratic equations which involves an imaginary number? So it will happen because on our previous lesson, when we solve for a quadratic equation and it ends up with a negative number inside the radical, we always write undefined. But this time, we're not going to write undefined anymore. So for example, number 1, we have x squared plus 9 equals 0. To have x by itself, we need to perform 2 steps. The first step is to get rid of 9, and the second step is to get rid of the exponent by taking the square root of both sides. And now we end up with x equal to plus or minus the square root of negative 9. And we know that 9 is a perfect square, and the square root of 9 is 3, but since it's negative, we are replacing it with 3i. So it's not undefined, but it's plus or minus 3i. Now again, remember, when you're taking the square root of both number, it needs to have a plus or minus symbol in your answer. So we'll have 2 answers. So we know this is a quadratic equation. We know that we have 2 answers. It's x equals 3i and x equals negative 3i. Now for number 2, we have x squared plus 3 equals negative 7. We need to have x by itself. We need 2 steps to get rid of the number and the exponent. So we'll end up with x squared is equal to negative 10. Taking out the exponent by taking the square root of both sides, we have plus or minus I squared of 10. And why is it I squared of 10? Because 10 is, we cannot simplify 10 anymore, so we'll just leave it as 10 inside and I outside because we don't want a negative inside the radical. So once again, we have 2 answers. We have x equals I squared of 10, and we have x equals negative I squared of 10. And for our last example, we have x squared minus 2 equals negative 14. Have x by itself using 2 steps, and we'll end up with plus or minus the square root of negative 12. Now 12 is not a perfect square, but we can simplify it. The factors of 12 will be 4 and 3, and we know that 4 can be simplified into 2 because square root of 4 is 2, and I is outside because we have a negative number. So the final answer will be x equals plus or minus 2i square root of 3. Once again, we have 2 answers. One is positive 2i square root of 3, and the other one is negative 2i square root of 3.